Assalamu alaikum. My name is Muhammad Haris Siddiqui, and today I have to explain these questions. So let me share my screen. Okay. So basically, the question is merge k sorted list. You are given an array of k linked list. Uh, each linked list is sorted in ascending order. Merge all the linked lists into one sorted list and return it. So basically, example one, there's three lists in a list. What we have to do is we have to first merge it, and then we have to merge all the lists, and then we have to sort it. So the output will be like this. The three lists are 145, 13426. We first merge them and then sort them into one sorted list, and then we have to return that list. And if the list is empty, you will return null value. If it is an empty list within a list, you have to return null value as well. So let me explain the. So basically, I've done this by simply using the merge pattern. It has a time complexity of n log k. So, and the constraints, like look at the constraints, list length should be equal to uh, k, and k value should be less than equal to greater than equal to 0, less than equal to 10, and the value within list values should have a length of greater than equal to 0, less than equal to 500, and the values within the list should be greater than minus 10 to the power 4, less than 10 to the power 4. The list is in ascending order, as it is told that the inner list will be in the ascending order, and the sum of length will be list length will be not exceed 10 to the power 4. So firstly, what I did is I used this condition basically to check that if there's any empty list or there's any list, if there's no list within a list. So we will return none, like in this example, and this as well. So return none. Then I will use the while uh, uh, statement. It is checking that if the length is greater than one. If it is greater than one, then we take a variable merge list, empty list. After that, I divided the list into two parts basically. So for example, if I had 1, 3, 5, 4, firstly I would check this, I would merge this. After that, I would merge this, and at the end I would merge them. I would merge them into one list and then return it. So that's what I'm doing here. Right here, I'm basically dividing them into two parts. L1 will be one list, and L2 will be second list. And I've used this condition because of the fact that if it can exceed it can exceed the length of the list. So I've used that if it is in comes in the boundary of the list, you can use this. L2 can be uh, that list, otherwise return L2. L2 will be none. There's no any problem comparing empty list with a non-empty list. After that, I've I've I will send these list into a function. I will explain later. And after I get the list, I append them into an empty list. And then I turn that list into the given list, and then I check the condition if length is not equal greater than one. If there's only one list left, so we return that list. So let me go through the function. Firstly, what would I do is send the list in this merge list. It is doing it is I've taken a empty node which is called dummy as well as tail, and I check that while there's L1 and L2, if L1 value is greater than L2 value, if it is okay. So let me clear all this. So what I did is I take a tail node, or you call it as dummy. What I did is, firstly, I would check that, for example, if we had 1, 3, and 5 and 4. Firstly, it would check that if uh, 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 1 is greater than 3. If it is if it is less than if L1 is less than 2, yes, it is less than 2, it will be 1. Dummy next will be next, then tail next or dummy next will be 1. Then it will check it's 3 is less than 5 or 5 is less than 3. Yes, 3 is less than 5. So we will do like that. After that, 5, 4, 4 will come and 5 as well. These conditions are used to for comparison that which value is greater, which value is less. And which values will be lesser, it will be considered firstly. After that, I update the tail node. It will updated uh, every time. So we use this condition, this condition, this condition. So after that, for example, if we had a case like for example, if one list had 1, 3, 5, and another list have length greater than L1. So uh, what we do is 3, 5, 7, 8, 9, 8, 9, 3, 2, 5, 7, 8, 9. So what we do is we take these other variables in the L2 and then merge them into tail next. So we check in this condition that if L1 if there's any L1 left, we will uh, uh, we will what we do is we take the remaining L1 nodes and then append it into our tail next. If there's so one of the nodes, one of the list will be empty, either L1 or L2. There will be no non-empty in the no non-empty two lists. So basically, what I do is I return the dummy next, and dummy next will be appended in merge list in this, and after that merge list will be equal to list, and it will check the condition if length of the list is, if there's only one list left, we will return the given list. So let me check the drawing. Let me check the solution. After that, you can see that it is faster than 83%, so it's quite faster. And as I told that it has a time complexity of n log n log k, n log k. Where is that? So time complexity will be n log k, and space complexity would be, because of the fact that I'm using another data structure list, so it will be O of n, which is merged list in this case. So time complexity will be n log k and space complexity will be O of n. And edge cases would be like if there's no in a list of there's no any list, so we will return none. So I used that condition for that. Let's jump to question number 2. Uh, Share my screen. So the question is k closest point to. Uh, so okay. So the question is k closest point to origin. Given an array of points where points is x and y represent a point on the x plane and integer k, return the k closest point to origin 0, 0. The distance can be 2 points on the x plane is the equidistance between, that is x1 minus x2 square plus xy1 minus y2 square. We have may return the answer in any order. The answer is guaranteed to be unique except the order for that it is in. So the they are we have been given a list of points, and what we have to do is we have to return the list that is very close to the origin. For example, in this case, points is list points is 1 3 and -2 and -2 and 2. So case 1, it means that we have to return only one list that is closest to origin. In this case, -2 -2. And because how can we identify, how can we find the distance? We can find the distance by using this formula: x1 minus x2 square and y1 minus y2 square. For example, in this case, uh, x1 minus x, for example, x1, we have to find this the distance between 1 and 3 in origin. What we do is we x1 minus x2 square plus y1 minus y2 square, 3 minus 0. So x1 x and y1 points will be 1 and 3, and x2 and y2 points will be origin itself. So it will give an answer, and we will and at the last what we do is we will uh, uh, return the closest one, which is the minimum number, minimum distance. And let's see the example 2 as well. Points are these. We have to return two lists, which this is closest to. So 3 and 3 minus 2 and 4 will be the answer. The point's length should be greater than equal to 1, and the value of k is also, as well as it has to be less than 10 to power 4, and the points within the list are minus 10 to power greater than minus 10 to power 4 and less than 10 to power 4 as well. So what I have done is I have used the simply what I did is I firstly find out the distance, and then after finding out I push the numbers in the min heap. So uh, uh, it gives me a time complexity of k log n, and it is a very simple solution. So let's jump into it. So basically, I've initialized min heap. After that, I've used 2 points x and y points, and I found the distance between the origin and the points by using this formula, which is also given. And after the number which I get after getting a distance, I append that number into min heap, like the dist. I also append the distance number, and also append the uh, coordinates points as well in the min heap. After these three statements, my min heap is full of the minimum points, considering the minimum number to the minimum distance to the maximum distance. So firstly would be the minimum distance, and after maximum distance. If I will convert that into a tree, it will be a log of n O of n. It has a time complexity of O of n if. After that, I take a result variable while k is greater than 0, distance x and y, pop the numbers, and give those numbers into their respective variables. Like I will get distant number in this distance, and x and y points will be in x and y. So at the end, what I have to do is I have to return the points, not the distance. So what I do is I append the x and y points in the result variable, and use this statement to end the if k is equal to 0, it will pop out, and result would have our minimum number of points, minimum number distance points. So time complexity of this code will be uh, k would be time complexity would be k log of n, because of the fact that we are only taking k number of k number of k number of points, and because of the fact that we are popping only uh, popping from in heap, so our uh, not the best time complexity, I've forgotten the word, uh, the not the best time complexity. So log of n into k will be number of number of points we needed, and log of n is basically uh, worse. Sorry. So log of n will be the worst case, I've forgotten the worst word. So the worst time complexity of popping off the element from the main heap will be log of n, and k will be the number of items, where number of points we need. So time complexity would be this, and space complexity would be uh, uh, O of n, because of the fact that we are initializing. Um, so, there it is. So uh, O of n, because of the fact that we are using another data structure list and appending that numbers into a list. So space complexity will be O of n linear, and time complexity will be k log of n. And the worst case would be that if we have uh, many number of points. For example, if k is almost 10, so it would be a worst case, because we have to check we have to push every number and then typify it, and as well as we have to pop out and add it to result, so it will be log of it. So yes. Let's jump to question number third. Let me share my screen. So firstly, the question name is course schedule 2. There are total number of num courses you have to take, label from 0 to number of courses. We have given prerequisite and prerequisites. A and B indicate that you must take course B if you want to take course A. So for example, if example 1 is number of courses 2, so what we have to do is we have to take course 0 first before course 1. So we have to return number of courses in order which we have to take. For example, if there are total of two courses to take, to do cases, take course 1, you should have finished course 2. So the correct answer is 0 and 1. In this example, prerequisites are 1 0 2 0 3 1 3 2. Number of courses are 4. So if they have total number of courses to 4 courses to take course 3, you have to finish course 1 and 2. Like course 3, you have to take course 1 and 2, and for course 1 and 2, you have to finish course 0. So the correct order is 0 1 2 3. And then there are no courses to take. We are only one course, so we will return 0 in that case. So what I did is I did this question by topological sort. So firstly, what I did is I created a prerequisite in which I create a dictionary consisting of null values, null list. After that, what I take is I insert for every course in this statement. For every course, I insert its prerequisite. For example, for one, it will be 0. For two, it will be 0 as well. So it will be a dictionary. It will act as a map. So three things I have to look for in this example. Firstly, I would have to see is if if the uh, if that course which I have to look to, it is visited or not. If it is visited, if that course is visited, we do not have to visit it again. And if it if the course not added to not added to output but added to cycle, we have to see that if it is not added to the output but added to cycle, we have to add it into a cycle as well. Unvisited, if the course not added to output or cycle, for example, if it is never been gone through the output or cycle, we look into the depth the uh, after. So output will consider an empty list. Then we'll take a visit and set visit and cycle, which will be a set firstly. So then I run a DFS. In DFS, what I do is I see that if it is a cycle, for example, if it's prerequisite, or if it's prerequisite also visited. So what we do is we return false. If it is in a course is in visit, we return true. We will then add the course into the cycle, and then I for prerequisite, and then I check that if that prerequisite is false, if it means that if it is visited, then return false as well. Then after that, what I do is I remove the course form cycle, which is a set, and then I add that cycle into our visited set. After that, I append that course into our output so that we will return we will get uh, our our courses in a sorted manner. After appending, I return it true. After that, what I do is I take foreseen range num courses. If DFSC is false, return true. It means that if number of courses, if it is a cycle, it will return false. Like there's no example in this, but if consider that if there was 1 0 for one you have to finish course 0, and if prerequisite have another course, like if for course 0 you have to finish course 1, so it is a cycle, so we will have to return empty list in that case. So I use that, so I use this statement. After that, if it doesn't if it is not false, then it return output at the end. So I will run it. Yes, it is. Yes, it is also submitted, and it is much faster than almost 70%. So it's quite faster. So the edge cases would be the, like I said, that if they are it is a cycle. If it is a cycle, then we have to return an empty string as well. And also the time complexity will be O of n, and our space complexity would be O of n as well, because of the fact that we are using another data structure, this output in this case. So yes, thank you for watching, and that's it. Okay, Allah Hafiz.